So I am Bennett Morales, and I entered the science fair at my school, Audubon, and here today I'm going to be explaining my science project. So my science project is called pH Matters, as you can see there, on pH, and pH kind of a plant's how they grow. And basically my experiment kind of had 4 parts. So the first part, we needed to make the seeds grow fast enough so that way they would be ready by the time the science fair started. So we looked up on the internet that when you scar seeds with sandpaper, it will make them go faster because they have to break out of that outer shell. And to start breaking down that outer shell will make them germinate faster. So, but we needed to test that first. So we tested that on 6 seeds. Well, these 3 on the top there, they were not scarred. Those were unscarred, those ones were scarred. And these ones down here were not scarred. And as you can see, these ones right here are the ones that the green is going, like you can see. And so we figured that based on that the scarred seeds were going faster than the unscarred seeds, that we should scar our seeds in this experiment. So then we wanted to try to do it to see how seeds grow using distilled water versus like acetic acid, where it has a very low pH at about 2.5. So we did that. So we had 2 pots of distilled water. Pot A was distilled water, and pot B was distilled water, and pot C was acetic acid vinegar. So then you can see there's some pictures right here of, I think these 2 ones are the ones in distilled water. But anyway, the seeds results were that the seeds in the vinegar, they would swell, and one of them we think even got close to germinating. So all the seeds swell, even the ones in pot A, pot B, and pot C. But only the ones in pot A and pot B germinated, and we think that was because the pH was too low. Plants like a pH of around 4 to 5, and 2.5 is way down on the scale. So we think it was too acidy for them to germinate. So then we wanted to do something. We wanted to try to see like where in between the distilled water, which is 4.5 and 2.5. We wanted to see where in between there did they stop being able to germinate. So we wanted to raise it a little, but when we did 3, and then we did 3 pots. We did 3.5, and then we did 4.5, and we did 5.5. But we used, to raise the pH of the acetic acid vinegar, we used baking soda, and we didn't know at first why none of our seeds were growing, and then we did some research on the internet, and we found out that the baking soda is toxic to the plants. So that's why they weren't growing, of course. So we had to figure out another way to raise the pH of vinegar, but something that wouldn't hurt the plants, or maybe would even be beneficial to the plants. And we came up with ammonium hydroxide. So we added that to acetic acid, and you can see the pH adjustment of that. So we added sodium bicarbonate to acetic acid, and what we got was sodium acetate and carbon dioxide, which were the bubbles that were rising when we did it, and H2O water. So that's the equation for that. And I'll come over here and show you the results on the 4 pots that we did. Let's see, we did, oh man, 4.5, which was pot G, pot I, 6.5, pot H, 8.86, and pot J for 8.86, and pot H, which was 5.5. So we did 4.5, 5.5, 6.5, and 8.86. And what we got was that 4.5 did very well, and because it was close to like what plants like between 5 and 6, so that went well. And then we don't know why, but 5.5 didn't do very well. We don't know why, but it did, however, in its length, how much it swelled, it got the most. So you can see over here, pot H, 5.5, and in our graph, it was tied with pot I, which was 6.5, and it was the last place on its radical. The radical is like the first part of the seed that comes out, the main root. And so it didn't do very good on that, but its swelling, how big the seeds got, it did the most well on that. So that's interesting. And then basically so the 8.86 right here, I think actually that on the first stages, which is what we were measuring, it did well, but once it got, or in the first stages it did okay, but then once it got into like more of its growing part, where it gets leaves and stuff, it was doing the best. And I think that, and I researched that, and my results on the internet were that the ammonium, so 8.86, that's the highest pH, which means that it had the most ammonium in it. The ammonium hydroxide, it helps the plants when they are past their early stages. So that's why that did well. So that's about the end of that. But now I'm going to go to the chemicals over here. So the chemicals were the chemicals that we used. My grandpa helped me make a very special chart like this on the computer, and we used, let's see, hydrogen ion, hydroxide ion, acetic acid, which is vinegar, acetate ion, sodium bicarbonate, baking soda, and sodium acetate, ammonium ion, ammonium hydroxide, and ammonium acetate. So you can look here, the code, what we used to write for it, and the structure, what it basically looks like, and the structure in 2D, like if you were just drawing it. Those are the pictures. And then I got a ribbon, Audubon Elementary School participant, science fair. So, see you later.